So in this video, we're going to be talking about lab 13, which is you're looking at the solubility of two specific compounds uh, as a result of change of temperature. All right, so there's dependence on temperature, dependence of the solubility on temperature. So there are two components in a solution. It's the stuff that gets dissolved and the other component which is in excess, which is the solvent. All right, so the solute is in the lesser amount and the solvent is going to be in the greater amount. In this case, the solutes for this experiment are different ionic compound, and then the solvent is water. All right, so the mass of the solution includes the mass of the solute plus the mass of the solvent. Right, solubility itself is defined as that amount of solute that can dissolve in a fixed amount of solvent, and then this solubility then varies when the temperature of the solvent is changed. All right, for example, sodium chloride, right, in a given amount of solvent, say 100 grams of water, all right, about 39 grams of it would dissolve. All right, so the solubility of sodium chloride would then be 39 grams per 100 grams of water. All right, and the temperature, of course, would be at room temperature. And then as you vary the temperature, you will also study how much of sodium chloride can dissolve in 100 grams of water, keeping that water amount constant. Okay, to see how much of this sodium chloride can dissolve as you increase the temperature. Typically, as you increase the temperature, more of the solute should be able to dissolve in that same fixed volume of water, or a fixed mass of water, as in this case the solvent is water. So as the temperature of the solvent increases, the solubility also must increase. You're able to dissolve more of that solute into that same amount of water, all right, as a general rule. But that doesn't mean it applies to all solutes, right? Sodium chloride, for example, its solubility hardly changes. Even if you take the temperature up to 100 degrees centigrade, its solubility doesn't change. Okay, so at 0 degrees centigrade, when it's freezing, about 36 grams of sodium chloride can dissolve in 100 grams of water. Now, when you bring that temperature to boiling temperature, 100 degrees centigrade, you would imagine that more of the sodium chloride can then dissolve in 100 grams of water. And it does marginally, all right, 41 grams. It goes up from 36, about 5 grams more, all right. But essentially, it's kind of remaining in the same ballpark, all right, very similar, all right. So sodium chloride solubility doesn't increase much at all. Okay, so it's almost like it is independent of temperature. A fixed amount is only able to dissolve in 100 grams of water. This is not the case with other solutes. Okay, so potassium nitrate, for example, all right, at 0 degrees centigrade, 14 grams of potassium nitrate is able to dissolve in 100 grams of water. But once you raise that temperature, you see that 245 grams of potassium nitrate is dissolving in that same 100 grams of water. So it has considerably gone up from 14 to over 200 grams, all right? And now this is typical. Most times you can see this even in a common everyday example like dissolving sugar, right? As you increase the heat of the water, you can dissolve a whole lot more sugar than at room temperature. So another compound, ammonium chloride, also acts very similarly. So the solubilities of potassium and ammonium chloride increase with increase in temperature. Now what we're going to do is use 10 grams of water. All right, so it will be considerably smaller, the amounts of KCl and ammonium chloride. However, what we are going to do is we're going to multiply once we get the results by 10. All right, and I can show you with the data table what I mean. That way we are prorating it to 100 grams. Okay, so we start out with 10 grams of water and we gradually increase the amounts of the solutes as we increase temperature. All right, and then you are going to plot graphs for what is called as the solubility curves. That is, you're going to plot the solubility versus temperature, okay, using your data points. So you're going to take a test tube in the first experiment, which is potassium chloride, KCl. So you're going to start out with 3.5 grams of KCl and you'll add it to 10 mils of water. Remember, the density of water is 1 gram per mil, so 10 mils should weigh 10 grams. Okay, so you're dissolving 3.5 grams of KCl in 10 grams of water. And now all of it may or may not dissolve. All right, some might remain undissolved. So what you're going to do is take this test tube, drag it to the constant temperature bath, which is going to be set at 80 degrees centigrade, attach a thermometer to the test tube and see that the temperature gets up to 80 degrees. All right, wait till all that KCl dissolves into the water at this 80 degrees centigrade. If it doesn't dissolve, then you can go up a little bit higher, but make a note of this higher temperature in case it's not the 80 degrees centigrade. Now what you're going to do is remove this same test tube to the workbench and let it cool. Now this is the point where you'll have to be quite observant and not let your eye off that test tube. All right, as that KCl solution is cooling down, record the temperature at which that solid KCl first starts to appear in the solution. All right, so that means all that excess KCl is going to come out of solution. All right, so this temperature is called as the solubility of KCl at that particular temperature. All right, so you are starting out with the 3.5 grams and then you're going to repeat the exact same thing with 4 grams. All right, so you're going to add 4 grams to 10 mils of water, heat it up to 80 degrees centigrade, cool it back down and note the temperature at which that KCl starts coming out of solution. All right, so as soon as you first see the KCl coming out of solution, note down that temperature. That is the temperature of solubility for the 4 grams. All right, so the temperature of solubility of 3.5 grams would be a different temperature. This should be higher, and then you're going to repeat this with 4.5 grams and then with 5 grams of KCl. All right, so at each point record the solubility temperatures for each of these listed masses. Now do this exact same thing for experiment 2, but this time with 4 grams of ammonium chloride. So for potassium chloride, you started out with 3.5. Here you're starting out with 4 grams. And then you're going to add it to 10 ml of water. Again, some of it might remain undissolved. So you're going to heat it up to 80, cool it back down, and then again note the temperature at which that first sign of ammonium chloride coming out of solution. All right, and note that temperature at which that happens. So for ammonium chloride, your starting point is 4 grams, and then you're going in the next set to 4.5 and then 5 and then 6. Okay, so again record the solubility temperatures for each of these corresponding masses. All right, so this is what the data for KCl will look like? At room temperature, 21.6 degrees, 3.5 grams is dissolved into 10 mils. Okay, so if I multiply the numerator by 10 and the denominator also by 10, it comes out to be 35 grams per 100 mil. Okay, now when I increase the temperature to 40, increase the amount of solute to 4 grams, that corresponding temperature for solubility is 40.2 degrees centigrade. All right, so that is the corresponding for 40 grams of KCl in the 100 grams of water or 100 ml of water. Okay, similarly for the 45 grams it's 57.4, and then for the 50 grams it's 74.9. So when you do the plot, solubility goes on the y-axis, temperature on the x-axis. Now in your when you're using the graphical function in late night labs, as I said, it automatically does the trend line, especially if you click on trend line, and then what happens is you only see one line. You may not see the separated lines like I have here, because they might just condense into one line, all right, because they're superimposed one on top of the other. So if I take this line, because the first data point is starting over here at 35 grams, and then the corresponding temperature is here. So if I then extend this line to cut the x-axis at 0 degrees centigrade, all right, then my y-axis will indicate the intercept, all right. So this seems to be around 29 grams of KCl per 100 ml of water, all right. What is the percentage difference between the data points at 60 degrees centigrade? There is nothing, no difference. It's 0, because both of the lines are superimposed. They have the exact same data points, all right. The data are exactly the same for the experimental as well as the official. So the percentage difference is 0. The amount that the solubility amount that corresponds to 60 degrees centigrade seems to be here, and that again you can do this mathematically using the straight line equation, and that is coming out to be 47 grams per 100 ml of water. All right, so I get another set of data for the ammonium chloride, experiment 2, and so again you just multiply both the numerator and the denominator by 10, all right. So 40 grams per 100 mil, the starting point is 26 degrees, and as you're getting up to 70.1 degrees, you can see that from 40 it went up to 60 grams, all right. So gradually increased the amount of sodium ammonium chloride that you were able to dissolve in the same volume of water. And then you get another plot like so, which again shows that the intercept here is around 29 grams per 100 ml of water. Okay, so the aim was to determine the relationship between solubility and temperature for potassium chloride and for ammonium chloride. Okay, my prediction is that for both ionic compounds, these ionic compounds are extremely soluble in water. They dissolve really well in water, and so for most ionic compounds and most substances, solubility will rise with a rise in temperature, all right. That is, more of it will then go into solution, all right. So my prediction is that as the temperature increases, the solubility of these compounds in 100 ml of water will also increase. I will stop here and continue this in the next video.